Dear students, welcome to the lecture series on the topic Engineering Graphics. So today we are going to discuss about Introduction to the Projections of the Solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now the solid is an object which is having three dimensions, that is length, breadth and thickness. So to represent a solid onto a flat surface having only length and a breadth, that is our drawing sheet or the screen of our computer, at least two orthographic views they are required. So sometimes additional views projected on the auxiliary planes, they become necessary to make the description of the complete solid. So this will be required when we have the surfaces of the object which are inclined to the principal planes, that is the horizontal plane or the vertical plane. So this we have already discussed while we were discussing upon the auxiliary planes. So the auxiliary planes, they were required to present or project true shapes of those surfaces which happen to be inclined to a particular reference plane, because their projections cannot be obtained on the reference planes to which these surfaces they are inclined to. So that is why additional views will be required in certain cases. So the study of projections of the solid, they are important in mechanical design problems and also solving the 3D modeling and the animation problems in the industry. Now the basic solids are those solids which are having the predefined shapes, and the basic solids, they are the constituent parts of any complex solids. That is, whenever we look at any industrial object or the big object, we will find that the objects in the real world, they are made up of the combinations of the basic solids that we have. Now we can classify solids in multiple ways. The first classification of the solids is based upon the orientation of the axis. So we can, based upon the orientation of the axis, we can classify solids into two categories. The first one, the right solid or the true solids. So these are the solids which are having axis perpendicular to their base, whereas the oblique solids are the ones which are having axis inclined at an angle other than 90 degree to their base. Then the second classification of the solids is based upon the shapes of the solids. So based upon the shapes of the solids, we can classify solids into two broad categories. The first category is regarding the polyhedra. So polyhedra are the solids which are bound by plane surfaces. So any solid which is bound by any number of plane surfaces will be called polyhedra. Then the second type of solids based upon shape, they are called solids of revolution. So these solids, they are obtained as a result of rotation or revolution of a given plane surface. So these are those solids which are going to have curved surface on their outer side. So we are going to discuss about all these solids, categorization of solids one by one. So the first classification, that is based upon orientation, will see true solids or the right solids. So a true solid or a right solid is one which is having its axis perpendicular to its base. So here you can see number of prisms, they are shown over here, in which we can observe that in every case the axis of the solid happens to be perpendicular to the base. So we can say that all these solids, they are resting on the ground in an upright position, that is axis is at an angle of 90 degree. And especially in case of the prisms, we must see that in case of a true prism or in case of a right prism, the two opposite faces of the prism, they are joined with the help of rectangles. You can see these are all the prisms where there are two equal and similar opposite end faces which are joined with the help of rectangles over here. So in case of true solid or the right solid, the two end faces of the prisms, they will be joined with the help of rectangles. Now let's move on to the oblique solid. So the oblique solids are the ones which are having their axis inclined to their base at an angle other than 90 degree. So these solids are not standing upright, they are not inclined, they are not having their axis inclined at an angle of 90 degree. So their axis is inclined with respect to their base at an angle other than 90 degree. So this is the oblique cylinder. So here you have the oblique cone, and now this is the prism. So you can see in this prism, the two opposite end faces of the prism, they are not joined with the help of rectangles. These prisms, the prism opposite end faces, they are joined with the help of rectangles over there. So since the axis is inclined to its base, so the opposite end faces, they are no longer joined by a rectangle. This is the oblique pyramid, right? So this is the classification based upon orientation of the axis. And usually whenever we look at engineering constructions, you will find that 95% of the engineering constructions, they will be standing tall and standing upright. Most of the engineering buildings, engineering machinery, engineering components, they will be standing tall and upright. But for the purpose of requirement, maybe engineering requirement, or even for architectural purposes, there are many installations, they are made inclined. There are number of buildings or number of installations are there, monuments are there all over the world, which are not designed straight, but they are designed inclined. So those solids, we are going to say that they are oblique solids basically. Now the next classification is based upon the shape of the solid. So depending upon the shape of the solids, we can classify solids into two broad categories, that is polyhedra and the solids of revolution. So the examples of the polyhedra, they are regular polyhedra, prisms and pyramids, whereas the examples of the solids of revolution, they are cylinder, cone and sphere. Now we are going to discuss about all of these one by one. So let us first of all start with the polyhedra. So the polyhedra are the solids which are bound by plane surfaces. So any solid which is bound by plane surfaces will be called polyhedra. And polyhedra can be further subdivided into three categories. First category is the regular polyhedra, second one is the prism, and the third one is the pyramid. Now the regular polyhedra, as the name suggests, regular, so it means that all the faces of the solid, that is, it is bound by different plane surfaces. So the solids which are having all their faces similar, equal and regular, they will be clubbed under this category of regular polyhedra. So in a way we can define regular polyhedra like the solids which are bound by similar, equal and regular plane surfaces. So those solids will be termed under the category of regular polyhedra. So the first example is tetrahedron. So a tetrahedron, it is a regular polyhedron having four equal equilateral triangular faces. Just see, this is an example of the tetrahedron in which there are four equilateral triangles. You can see the base of the tetrahedron is a triangle, equilateral triangle, and then these are three further equilateral triangles which are joined at the apex over here. So the four equilateral triangles, they are binding the surface. So tetrahedron is bound by four equilateral triangular faces, right? Then the second one is example of the regular polyhedra, it is a cube. So cube is also known as a hexahedron, so because it is having 6 square faces. So 6 means hexa. So cube is bound by 6 square faces. So cube, it is a regular polyhedron having 6 equal square faces, and it is also known as hexahedron. So just see, here we have 6 equal and similar faces are there. So shape of each and every face is square and the size is also the same. So here again, shape of all the four faces, that is, it is equal to equilateral triangles, and the size is also the same in all the four faces over there. And once we draw this, now you can have the terminology basic, that is, this is called the edge of the base. This is again, all these are the edges. If we are talking about the base, we will call it edge of the base. Otherwise, this is also an edge, this is also an edge, this is an edge, this is the edge of a tetrahedron, this is again the edge of a tetrahedron. Similarly, you have this as the edge of the tetrahedron. Then these are the faces. So this figure will have, that is, tetrahedron will have 4 faces, and all the faces will be equilateral triangles. Similarly, the square will have 6 faces, all the faces will be square, and they will all have the same size as well. So shape will be the same, size will be the same. Then these are the corner. So these 3 things we want to remember, because we are going to use these terminology when we are discussing about the projections of the solid. That is, we have to draw the front view and the top view of the oblique solids. So the oblique solids will be once again the ones which are inclined to both the horizontal plane and the vertical plane. So there we need to remember this terminology. This is the corner, these are all the edges, but whatever edges are lying on the base, we call it edge of the base. So we can say that a tetrahedron is resting on the ground on the edge of the base, then it will be resting over here, not on this particular edge over here. So these are all the edges of the base, and these are the other edges of the tetrahedron. Similarly, these are the 4 edges of the base. So if a cube is tilted in any orientation, it will be resting either on the edge of the base or it will be resting on the corner of the base. Similarly, the tetrahedron, if it is tilted in any orientation, it will be resting either on the edge of the base or it will be resting on any one of the corners of the base. So this basic terminology we need to remember. Next, we have the regular polyhedra. Further examples, octahedron. So octahedron, it is a regular polyhedron having 8 equal equilateral triangular faces. So please see, octahedron will have a square center over there, and 4 triangles will be joined at the apex on the top, and 4 triangles will be joined at the apex at the bottom. So you will have a square center over there, then 4 triangles, they will be joining at the center. Similarly, 4 triangles down the side, they will be joining towards the bottom. So here you can see, this is a square, intermediate portion is there, and then 4 equilateral triangles on top side and 4 equilateral triangles on the bottom side. So octahedron has got 8 equilateral triangular faces, and it is basically following the square pattern. So on the square pattern, on the top side 4 equilateral triangles, they are joining at this point, and on the bottom side also the 4 equilateral triangles, they are joining downside. Then another example of regular polyhedra, it is dodecahedron. So dodecahedron, it is a regular polyhedron having 12 equal and regular pentagonal faces. So in the dodecahedron, there are pentagonal faces, so the shape of the face has changed. So in tetrahedron and octahedron, you had equilateral triangles. In cube, you had the face as your square. So here your face is changing to pentagon. So there are 12 pentagonal faces. So there are 30 edges and 20 vertices in this particular case. Then the final example is isosahedron. So in case of isosahedron, it is a regular polyhedron having 20 equal equilateral triangular faces. So once again, there are equilateral triangular faces, but this solid is bound by 20 equilateral triangular faces. So this solid is termed as isosahedron. So all these examples, they pertain to the regular polyhedra, since in all of these cases the solid is bound by, first of all, the plane surfaces. Second, all the plane surfaces, they have the same shape, and all these plane surfaces, they have the same size as well. So the pattern of the face might change, but other conditions, they will be fulfilled in case of regular polyhedra. Then the second category of the polyhedra, they are prisms. So in a prism, there are 2 equal and opposite. Please see, there are 2 equal and opposite similar end faces, there are two equal and similar end faces are there which are lying on the opposite side parallel to each other. This face is parallel to this face, whether this solid is an oblique solid or whether this solid is an oblique solid or a true solid. So both these faces, they will be parallel to each other and they will be joined by other rectangular or parallelogram faces. So this thing we have already discussed. Whenever you have the true solid, that is the axis is perpendicular to the base and the solid is standing upright position, then the two opposite faces of the prism, they will be joined by rectangles. And if you have an oblique solid, so these rectangles will be replaced by the parallelograms, right? So now you can see, while we are discussing the basic classification, now I am also going to tell you about how do we do the naming of each and every point, how do we locate the axis of every solid over here. So please see, this is a prism, because prisms and pyramids, this is the maximum, so these are the maximum solid problems that we are going to undertake during the projections of solid study. So please see, once we have this triangular prism, so what do we mean by triangular prism? That the base of the prism is a triangle. So all the prisms, they are named after the shape of their base. So if the shape of the base happens to be triangle, we will call it a triangular prism. If the shape of the base happens to be a square, we are going to call it as a square or the rectangular prism. Similarly, if the opposite faces of the prism, they are the pentagon or the hexagon, then we are going to term those prisms as pentagonal prism or the hexagonal prism. Now let us start with the basic terminology of the prism. Whenever we have the prism, you see, it is nothing but it is the extension of the plane surfaces. So the plane surface is going to give the name of the prism. In this case, the name of the plane surface or the base is triangle. In the other case, it may be rectangle, it may be square, it may be parallel, it may be pentagon, it may be hexagon. But it is nothing but a prism can be obtained by extrusion of a plane surface vertically upwards, basically. So we have already discussed about the projections of the planes. So in projections of the planes, whether you orient it with respect to HP or VP or both, all the faces, they are visible all the times. But in case of solids, there will be certain faces which will be visible, there will be certain faces or the edges which will not be visible. So those edges of the solids which are not visible will be drawn with the help of dotted lines, and those edges of the solids which are visible, they will be drawn with the help of dark lines or HB line, or we call them object lines over there. Now let us do the naming. So I can name this solid as A, B, C and then D, E and F. If I name it this way, every time I have to remember that A has to be joined with D, B has to be joined with E and C has to be joined with F. So there may be some confusion. So what we have to do, please see, every time we have to name any solid, we will be naming it this way. A, the lower corner of any vertical edge. Please see, the lower or the upper corner of any vertical edge can be named as A and the opposite corner can be named as 1. So that we easily remember that A and 1 have to be joined over here. Similarly, the second point, B, so it will have the opposite corner to be named as 2 always. Similarly, you have C, that is the opposite corner of C will be named 3. So you can see there are two plane surfaces over here. So the first plane surface, which is quite obvious, this is ABC, very easy to remember. Second surface of the prism, it is 1, 2, 3. So whenever we draw any prism, we remember very easily that this surface has to be joined. ABC, this is the lower surface or the surface of the base. The upper surface, that is the top surface, 1, 2, 3. Again, these 3 points have to be joined. Then another thing we need to remember, A and 1 has to be joined with the help of a vertical projector. 2 and B have to be joined because this is the vertical edge of the solid. Similarly, C and 3 have to be joined because it is again the vertical edge of the solid. So for any solid, you see, all points of the surface, upper surface as well as the lower surface will have to be joined, and all the vertical edges again they have to be joined. Now the question remains, the edges or the faces which we are able to see from the front side or the top side, they will be drawn using the object line or the darker line. The edges or the surfaces which we are not able to see from the front side, which are overshadowed or overpowered by the front faces, so they will be drawn with the help of hidden line. That is, these edges they have become hidden over there. So the first thing we need to remember, all the points of the lower surface, that is the base, have to be joined. All the points of the top surface, that is the top of the solid, have to be joined, and all the vertical corresponding edges have to be joined. So by naming it A1, B2 and C3, we remember, very easy to remember, that these vertical edges are also to be joined. Now the second thing which is required in any given prism or any given pyramid is to evaluate and locate the axis of the solid, because in solids two things will be given. The edge of the base will be provided, that is, if it is a rectangle, then length and breadth of the rectangle will be provided. If it is a triangle, let us say this is an equilateral triangle, then the edge of the base will be the edge of the triangle over there. So one edge of the base will be provided and the axis height will be provided in any given prism or a pyramid. So only two things are required, and you are required to carry out the construction of the front view and the top view of the solid. So for every solid, we need to understand the basics about how do we evaluate the axis of the solid. So please see, if it is a triangular solid, first thing we have understood that the how to do the naming. So the base you can name as 1, 2, 3 or ABC. Top you can name as 1, 2, 3 or ABC. So if you are using ABC over here, you can use 1, 2, 3. If you are using 1, 2, 3 over here, you can use ABC over here. Next thing, all the points of the base and top have to be joined first. Second, the corresponding vertical edges need to be joined in every case, irrespective of whether they are visible or not. If they are visible, they will be joined with the help of the object lines. If they are not visible, they will be joined with the help of the hidden line. Next, we need to evaluate the axis of any given solid. So please check out over here, if it is a triangle, how do we evaluate the axis of the triangular prism or a triangular pyramid? So please see, whenever we have the base, what we are going to do, from every corner you mark the midpoint of the opposite side. That is, we have to have the bisector of the opposite side. So this will be the bisector of AC, this will be the bisector of AB, this will be the bisector of BC. So from A, I am going to join the bisector of the BC. From B, I am going to join bisector of AC. Similarly, from A, I am going to join bisector of BC over here. And all these three bisectors, they will be joining at a common point. Similarly, over here, from 2, join with the help of a construction line, the bisector of 1, 3. From 3, you draw the bisector of 1, 2 over here, that is, draw a construction line which will be joining the midpoint of this. From 1, again you draw a construction line which will be joining the bisector of 2, 3. Just see, now this is the way I have drawn all these three bisector. From 2, it is this bisector. From 1, it is this bisector. From 3, it is this bisector. So wherever these two bisectors, they are going to meet, all these bisectors either in the front or in the top, this gives me the axis point. So the axis point I can name as O over here, and this will be named as O1. I can name this as O or this as O1 as it likes you. So please see, one of the midpoint of the axis I will name as O1. Second point of the axis I will be naming as O. So these are, you can see, construction lines which I have to draw in order to obtain the center point or the axis point of a triangular lamina. So this is how you locate the axis of triangular pyramid or the triangular prism. Now the next one is square prism. So as I told you earlier, that the name of the prism is based upon the shape of the plane figure which is there as its base. So in over here, the plane figure over in the base is our square. So since you have two opposite faces which are square, so we have called it as a square prism. Now as I told you earlier, not all the edges of the object or the solid will be visible. So those edges which are away from the observer, they will not be visible to you. So they have to be drawn with the help of hidden line, that is dotted line. And those edges of this object which are visible to you, they have to be drawn using the object line. And once again the naming, so naming will be, otherwise if I don't have this 1 2 3 and ABC, A B C D, then E F G H, then I have to remember A has to be joined with, okay, A B C D E, so E has to be there corresponding to A. B, then F has to be there, then it is C, then again G has to be there, then D, then H has to be there. So you have to remember a lot over there. But if I have the simple numbering, you can name A, this will be 1. You can name this point as B, this number will be 2. Very easy to remember. Number 3, this edge corner name is C, so here this corner name is 3. Now this is D and 4. Now whenever you make any construction of the oblique solid, one thing is very clear. A, B, C, D have to join under all circumstances. 1, 2, 3, 4 have to join under all circumstances. Similarly, A1 must be joined, B2 vertical edge must be joined, C3 vertical edge must be joined, and D4, that is the vertical longer edge, again must be joined. So this way, if we carry out the numbering in this way, it is very easy to remember which points and which edges they are to be joined over there. Now let us work out the center point of this or the axis point. So for the square or the rectangle, it is very easy. Find the midpoint of AD, find the midpoint of BC. So this is the midpoint of BC, this is the midpoint of AD. So draw the axis line passing through these two midpoints. Similarly, find out the midpoint of AB, find out the midpoint of CD. So once you obtain these two midpoints, so once again pass an axis line passing through these two midpoints. So wherever this axis line and this axis line, they coincide with each other, you get the center axis point. Similarly at the top. So just see, this is the midpoint of 1, 4, this is the midpoint of 2, 3, draw one axis line. This is the midpoint of 1, 2, this is the midpoint of 3, 4. So draw another axis line. Wherever these two axis line, they intersect with each other, this gives us the principal axis of the solid. And once again, as usual, I can do the naming of lower point of the axis as O, or upper part of the axis I can name as O1, or vice versa. So please see, in case of any prism, the number of points which have to be dealt with, they are 2n plus 2. That is, if there is a triangular prism, then the edges of the prism, they are 3. So 3 edges at the bottom, 3 edges at the top. So 6 points you have to deal with, 2n plus 2 points of the axis. That is, in case of triangular prism, in every figure, in every projection, whether you are going to draw the front view or the top view, 8 points you are required to draw. For the square, 2n plus 2 means square is having 4 sides, or the 4 corners are there. So 2n plus 2 means 8 points will be there corresponding to the base and top, and another 2 points will be there corresponding to the axis. So 10 points you have to deal with. So let us work out different terms which we are going to use in projections of the solids. This is the top face. Please see, this is the top face of the solid. So many a time we may say that the top face is lying over here. So it can be the edge of the top face, or it can be the corner of the top face. So this is the edge and this is the corner. Next thing which we usually refer to in projections of solid, it is the axis. So please check. This is the axis of the triangular prism and this is the axis of the square prism. Third, longer edge. This is the vertical edge which is referred to as the longer edge because its dimension is higher than the base edge. So base edge is usually shorter, height of the prism is usually longer one. That is why we call it as a longer edge or a vertical edge. Next one, here you have the base. So this is the base. Usually we will be referring to the base. The solid is resting on horizontal plane on the edge of the base. If we are talking about edge of the base, it can rest on any one of these three edges. If the solid is there resting on the edge of the base, any four edges we can pick up. But if we say the solid is resting on the corner of the base, then these are the corners. So you see, this is the base. These are all the edges of the base. So even though we have marked only one edge of the base, triangular prism has got three edges of the base, whereas square prism is having four edges of the base. So it will be resting obviously on one edge of the base out of these four edges only. And finally you have the corner of the base. So here we go. This is the corner. Whenever we say the solid is resting onto the horizontal plane on the corner of the base, so it might rest on any one of these corners. So these are all the corners of the base. So but we must be able to distinguish between edge of the base and the corner of the base. So this is the edge of the base, this is the edge of the base, this is the edge of the base, this is also the edge of the base. So wherever any two edges meet, we get a corner. So this is the corner. Wherever we have marked these points A, B, C, D or 1, 2, 3, 4. So these are all the corners over there. Now next we move on to pentagonal faces. So please see pentagon also. Once again we are going to do the naming. First things first, please see all edges of the pentagon, they are not visible. So those edges of the pentagon which are visible to you from the side you are going to view this pentagonal prism, they will be drawn with the help of object lines. That is dark lines or HB lines we are going to draw. But those edges which are away from the observer, which the observer is not able to view, then these lines they have to be drawn using the hidden line. So had you been observing this pentagonal prism from the other side, then this would be visible, this would have been 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 visible, but then the edges at the back, they would have been becoming dotted over here. So this way it depends upon which side you are looking at the object. So since we are looking at the object from this side, so we are not able to view these edges. So that's why these edges they have been drawn dotted. So once again the numbering A1, B2, C3, D4, E5, and mind you, make sure A, B, C, D, E must be lying in a single plane. 1, 2, 3, 4, 5 they must be lying on the same plane, and numbering must be done so that A and 1 they should be facing each other along the vertical edge. B and 2 they should be facing each other along the vertical edge. C and 3 they should be facing each other along the vertical edge, and D and 4 and E and 5 they should be facing each other along the vertical edge. And again, one thing we must remember, whichever way this solid will be oriented with respect to HP or VP, we must join A, B, C, D, E under all situations. We must be able to join 1, 2, 3, 4, 5 because this represents a surface under every circumstances. Then we must also join A1, B2, C3, D4 and E5. And we must also join the axis line using the axis representation. So in case of a pentagon, how do we find the axis? Please see, from every corner there is the opposite base, there is the opposite end over there, opposite edge. So for all the 5 edges we will be determining the midpoints. Please see, we will determine the midpoints for each of the 5 edges of the pentagon. From every corner we have to drop a light construction line projector onto the opposite side midpoint. So 5 bisectors will be drawn over here. From here, same 5 projectors from the top and 5 projectors from the bottom. So please see, this is how I have proceeded. From 3, this is my projector to the midpoint of 1, 5. From 2, this is the projector onto the midpoint of 4, 5. From 1, this is the projector onto the bisector of 3 to 4. Similarly from 5, I have projector joining the midpoint of the edge 2, 3. So wherever these 5 edges join, I get the axis point at the top. Similarly at the bottom also, I am going to draw 5 projectors from the corners to the midpoint of the opposite edges over there. So wherever these 5 midpoints projectors they are going to join, they are going to give me the midpoints of the axis over there. So these are the axis location point. So from here you see axis I have drawn. So this point I have marked as O1 and this point I have marked as O. So again 2n plus 2 number of points have to be dealt with whether you draw the front view or the top view in any given construction or projection of solid. So since 5 edges are there, so n is 5, again 5 over here, 2n and 2 points for the axis. So 12 points we have to draw. So just like in projection of planes 6 views are required, so for drawing 6 views 72 points have to be drawn over there in projection of solids in case of pentagonal prism. Now you have the hexagonal prism. So this is called hexagonal prism because the shape of the base is the hexagon, number 1. So those edges which are away from the observer, which you are not able to see, will be drawn dotted. The edges which are visible to you will be drawn using the outlines or the HB line. Now let us do the numbering. Once again, since the 6 edges are there, so A, B, C, D, E, F will be there on the bottom side. 1, 2, 3, 4, 5, 6 numbering will be following similarly. So A1 on the first vertical edge, B2 will be the numbering which will be done on the second edge, C3 along the third, D4, E5 and F6. Now having done the numbering, we need to remember in every construction 1, 2, 3, 4, 5, 6 edges have to be joined. A, B, C, D, E, F, A edges again have to be joined. And vertical edges A1, B2, C3, D4, E5 and F6 have to be joined. And depending upon whether the edges are visible, we are going to draw it using visible line or the outline. If the edges they are not visible, then the hidden line or the dotted lines have to be used appropriately. Now in order to find out the axis point, it's very simple in hexagon. You join the opposite diagonal points. 1 and 4 you join, 2 and 5 you join, and 3 and 6 you join. Similarly, B and E you join, F and C you join, and A and D. So wherever these 3 diagonals meet at the bottom and at the top, you are going to get the location of your axis point. So F and C, just see A and D and B and F. B and D, they are all joining at one point. 1, 4, 2, 5 and 3, 6, they are also joining at the same point. So this is my uppermost axis point, this is my lower axis point. So the number of points which I have to deal with in every view will be 2n plus 2. So 6 plus 6, 12 and 2, 14 points I am required to draw. So in order to draw the projections of an oblique solid, that is oblique hexagonal prism, 84 points will be required to complete the given problem. So once again, the terminology, this is the top face, then you have the axis, please check, this is the axis point, then you have the longer edge or the vertical edge, next you have the base, and this is the edge of the base, so any edge of the base. So here you have the 6 edges, so any one edge we can pick up. Here you have the 5 edges, so any one of the 5 edges we can pick up. Then you have the corner. So in case of hexagonal prism, you have the 6 corners of the base. In pentagonal prism, you have 5 corners of the base. So any one corner we can pick up. So this is the terminology you must be conversant with if you have to attempt any of the problems related to projections of the solid. So next we move on to the pyramids. So pyramid, it is a polygonal face for the base which is connected at the edges to a number of triangular faces which are equal to number of sides of the base. So basically it has got a polygon face as the base. So there is a polygon face just like the prism. You can have triangular pyramid, you can see this is a triangular pyramid. The base of the pyramid is a triangle, and then which is connected at the edges to a number of equilateral triangular faces which are equal to the number of edges of the base. If there are 3 edges of the base, so 3 triangular faces will be there which are joining at the top, and this top point is called apex or the vertex. And just like in the case of prism, here once again you are going to get the similar terminology to describe this particular solid. And once again, just like the prism, only two things we are going to provide you over here. The first thing is edge of the base, and the second thing is the axis. So axis, once again, in location is very important. So let us see triangular face. We already know how do we work out the axis. So we do the numbering A, B and C. These are 3 points of the base, and the other 2 points we are going to number over here. The top apex point, that is the axis, it will be labeled as O or O1, and the bottom axis point of the axis we are going to name as O or O1. If this is O, this will be O1. If this is O1, this will be O. So let us first of all work out the axis. So in order to work out the axis, once again, from every corner join the opposite side bisector point. So you obtain the midpoint of every side of the triangle and join this with the opposite corner. So wherever these three bisectors they are going to join, this is going to provide you with the location of the axis at the base. So please see, once again I have drawn the axis. So if this point of the axis is O, top one, so this point will be called O1. If this is O, then you can call this as O1. So this is your triangular pyramid. Similarly, you have the square pyramid. So once again, in case of square pyramid, this edge is not visible. That's why we have drawn it with the help of hidden line. So let us do the numbering. So numbering will be A, B, C, D. And top point we have named as apex, we have named as O. Now how to find out the center point? This also we have discussed. Find the midpoints of each of the sides. So join midpoint of AD with midpoint of AC with the help of an axis line. Join midpoint of AB and midpoint of CD over here again with the help of second axis line. So wherever both of these axis lines, center lines, they join, this gives you the axis point at the bottom. So this is the axis point at the bottom. So join it vertically up, take it vertically up. So you will be getting the apex point accordingly. So this is how we work out the axis location in the case of pyramids. Now another thing you need to remember, in case of pyramid, number of points which have to be dealt with in any construction will be n plus 2, because in case of triangle 3 edges are there or 3 corners are there. So number of points in every figure will be 3 plus 2 equal to 5. In case of square, 4 edges or 4 corners are there. So 4 plus 2, 6 points you have to deal. So in case of projections of pyramid, oblique pyramid, then for every construction, front view and the top view, 6 points. So only 36 points will be required to complete a question regarding square pyramid. So questions regarding square pyramid, they are going to consume much lesser time as compared to the problems which are related to the prisms over there. So let us once again work out the terminology. The top points, they will be called as vertex or the apex. Then the second, all these slant edges, because these are all inclined edges. So all the inclined edges of the pyramid, they will be called as slant edges. Number 3, you have the axis. So we have worked out how do we evaluate axis in these two cases. Next, this is the base as usual. Then this is the edge of the base. Just see, this is the edge. So in case of a square pyramid, you will have 4 edges of the base. Any one we can pick up. Similarly, for triangular pyramid, you have the 3 edges. So any one of those edges we can pick up. Then you have the corner of the base. So this is the corner. So here you have the 4 corners, and here you have the 3 corners. So this is about the terminology, how do we do the labeling, how we go about working out the axis in case of the pyramid. Now next, we have the pentagonal pyramid. So please see once again, whichever edges of the pyramid they are not visible, they have been drawn dotted. Otherwise, the edges which are visible, they have been drawn using the object line. So the numbering once again, the base will be numbered as A, B, C, D, E, because there are 5 edges over here, and the top point will be labeled as O. And how do we find out the axis? We have already worked out, find out the midpoint of every edge. For every edge, work out the midpoint and then drop the projector joining the opposite corner and the midpoint of the edge. So just see, from E, drop a projector to join this midpoint of BC. From D, drop a projector to join the midpoint of AC. From B, drop a projector to join midpoint of DE. And same way from C, draw a projector to join the midpoint of AE. So from every corner you join a projector joining the midpoint of the opposite side. So just see, 5 projectors we have drawn from every corner joining the opposite midpoint of the edge of the base. And wherever these projectors they are going to join, so this projector point is going to give us, this intersection point is going to give us the axis point at the base. So from here, whatever is the axis height given, you draw the axis height and then you can draw all these edges over there. So this is how we work out the axis point in case of a pentagonal pyramid. Then you have the hexagon. So once again, the naming will be A, B, C, D, E, F. Now working out the center point, join the diagonal AD, join the diagonal BE and join the diagonal CF. So once you join all these diagonals, you get the center point or the axis point. So through this axis point, draw the vertical axis representation, small, big, small, big, small, big. So this is going to be your axis line. So this will provide you the axis. So in case of, once again, all of these solids, so number of points which have to be dealt with, n plus 2, n of the base, number of edges of the base, plus 2 points of the axis. So in order to complete the projections of the oblique hexagonal pyramid, so 6 plus 2, 8. So 8 points will be required for every projection. So in case of oblique pyramid, so 6 projections you are required to draw. 3 on the elevation side and 3 on the plan side. So 6 into 8, only 48 points will be required compared to 84 points required in the case of hexagonal prism. So this is much easier, that is pyramids, they are easier to handle as compared to your prisms. But otherwise principles remain the same. Now the terminology, this is the apex or the vertex, these are the slant edges, these are the axis lines, this is the base of the pyramid, then you have the edge of the base, this is the edge of the base, then you have the corner of the base. So same terminology will be used. And finally, classification of the solids, that is solids of the revolution. So as the name suggests, solids of revolution. So the solids of revolutions are formed by revolution of the plane figures like rectangles, triangles or semicircles about their fixed axis point. So here you see, if you have to obtain a cylinder, so all these solids of revolution can be obtained by rotating a plane figure about its axis. So please see, if we have to obtain a cylinder, we need to take a rectangular lamina. So this is our rectangular lamina. So about this axis line, if I rotate this rectangular lamina, this is going to yield be the generation of a cylinder. So the rectangular lamina is this one. If I rotate it all around, this is going to lead to generation of a cylinder. Similarly, a cone will be generated by rotating a right angle triangle about its altitude. So just see, the cone is generated by rotation of this lamina, which is the right angled triangle. So this lamina shape is right angle triangle in case of generation of a cone. So this has to be rotated about its altitude and this is going to yield the generation of a cone. Similarly, you have the third lamina, which is a semicircular lamina. So if you want to carry out the generation of a sphere, you can see this is a semicircular lamina. So if you rotate this lamina about its diameter, this is the diameter of this semicircular lamina. If you rotate it about its diameter, this is going to lead to generation of a sphere. So let us carry out the naming over here in the case of cylinders and in the case of cone. So here you see there are no fixed generators, just like your prisms and the pyramids. because there the generators, they were limited by edges of the base. In case of cylinder and cone, there are no edges. So it is up to you whether you want to divide your circle into 8 equal parts or you divide your circle into 12 equal parts. So depending upon whether you are dividing your circle into 8 equal parts or 12 equal parts, so many generators, artificial generators will be created. So this way we can work out these artificial generators, that is the imaginary lines generating the curved surface of a cylinder or a cone. So larger the parts in which you are going to divide your cone or a cylinder, more will be the accuracy of the surface or the shape which you are going to generate. So we can divide our circle or our cone into 8 or 12 equal parts. So in case of your cylinder, there will be vertical artificial generators. In case of cone, there will be the artificial slant generators over there. So you can name them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 if you are dividing it into 12 parts, or else you can start with 1. If you are divided into 8 parts, your names of the generators will be 1, 2, 3, 4, 5, 6, 7, 8. And on the other side, you can have A, B, C, D, E, F, G, H like this. So on one side, you can have 1, 2, 3, 4. On other side, you can have A, B, C, D. And A and 1, they will join. B and 2, they will join. C and 3, they will join. So this is how you will do the basic numbering and evaluation of the axis, because in case of circle, the finding out of axis is not difficult, because axis is the needle point of the circle, that is, it is the center of the circle. So no special efforts have to be made to obtain the axis in case of a circular object, because always we have the center point whenever we are going in for construction of a circle. So this is the basic introduction to the solids, their different shapes, how do we do the numbering, and this terminology we are going to use while we move on to the discussion regarding the projections of the solid. So with this introduction, we wind up this lecture, and in the next lecture we are going to discuss about the projections of the solids whose axis is inclined to either HP or VP or both of the HP and VP. So this is how you see, as I told you, the numbering has to be done. On one side you can have ABCD, on other side you can have 1, 2, 3, 4. Whereas in case of cone, depending upon number of parts in which you are going to divide it, so number of points, they will vary, right? So thank you very much. Thanks a lot. So with this, we end this basic introduction to the projections of the solids. So we are continuing with the actual projections of the solids, that is oblique solids, in the next lecture. Thank you very much. Thanks a lot.